So first of all, question 1. We have a parallelogram where these are the dimensions. We have 4 centimeters as the bottom length, 2.9 as the length of the side, and the vertical height is 2.5. And we need all of this data to be able to calculate the area and the perimeter. The area is quite easy. It's the length of the base multiplied by the perpendicular height, and that's it. So in this case it's nice and easy. We have 4 times 2.5, which is 10 centimeters squared, because this is 4 centimeters and this is 2.5 centimeters. Centimeters times centimeters is centimeters squared. You have to have centimeters squared to get the point. If you've forgotten the unit, you lose half a point. Then it says the perimeter. Well, we know that the perimeter of a parallelogram or any 4-sided figure is 2 times the length plus the breadth. The length is 4 centimeters plus, or the breadth here is 4 centimeters. The length is 2.9. So it's these ones that we use to calculate the perimeter. The perimeter is what's on the outside, and the area was what's in the middle. So 4 plus 2.9 is 6.9, and we just have to double that. 2 9s are 18, carry 1. 2 6s are 12, plus 1, 13. 13.8 centimeters. Perimeter is just all these different centimeters added up together. So we have a perimeter of 13.8 and we have an area of 10 centimeters squared. Then on this triangle here, question 2a, they've asked you to just calculate the area and they put all these measurements out that you don't need. The area of a triangle is just the length of the base times the perpendicular height, the one at 90 degrees to the base, whichever angle is coming down at 90 degrees, divided by 2. So the base here would be 40 centimeters because we need to add the 30 plus the 10. So the base would be 40. The perpendicular height would be 30. It's this one here where it meets the base at 90 degrees, divided by 2. 40 divided by 2 is 20, so we get 20 times 30. These are both in centimeters. So we get 2 6s, 2 3s are 6, 600 centimeters squared. So that's the area of that triangle. Most important here, remember when it's a triangle, you must divide the area by 2. You must also have units in your answer. What do you do then when you can't drop a perpendicular down in the triangle like this? Well, you draw these imaginary lines to give you the perpendicular height. So the important thing here is this 9, you don't use it at all. It's absolutely irrelevant to this question. The only thing you need here for the area of this triangle is the same formula, that the area of a triangle is the base times the perpendicular height divided by 2. The base of this triangle is the solid part here. So it's 8 centimeters times the perpendicular height, which has nothing to do with this 17 or nothing to do with the 23. It's the line that comes down, the imaginary line that comes down at 90 degrees to the base. So we have 8 times 15 divided by 2, giving us 4 centimeters times 15 centimeters. 4 15s are 60 centimeters squared. So the area of this triangle is 60 centimeters squared. Then, for question 3, so no talking please. Let's just concentrate on getting this corrected. Question 3, we have a square. And inside the square, we have a circle. Okay, pretend it's a perfect square and a perfect circle. I know it leaves a lot to the imagination, but what we know about this square is that the square has an area of 36 centimeters squared. So the first thing we need to work out, if we're going to be able to work out the area of the circle, is we need to work out what the length of each side is. And the length of the side will be the square root of 36, because we know that this area 36 is L times L. We know that the length of the side of this square is L. So we need to find the square root of 36. Which two numbers multiplied by each other give you 36?
6.
Well, 6 sixes give you 36. So the L must equal 6 centimeters. So you need to find which number. 36 multiplied by itself gives you 36, it's 6. So we now know that the length of our side is 6 centimeters. That tells us that the circle has a radius of half of that. So it's 6 divided by 2. So the circle has a radius of 3 centimeters. We can now work out the perimeter, the circumference of our circle. We know has the formula 2 pi r or pi d. So what would that be? Well, the radius is 3, so we would get 2 times 3 times pi, which is 6 pi. And I told you, because it was a non-calculator paper, you can use pi as being 3, so we get 6 times 3. So do an approximate sign here to show that you're assuming and define here as well. Pi is approximately 3. 6 3s are 18 centimeters. So our circumference, let's call it C, define our terms. C is 18 centimeters. Then they wanted the area. Well, the area of the circle we get by, let's call it A, pi r squared, which is pi times 3 squared. 3 times 3 is 9, so we get 9 pi. And we again assume pi is approximately 3. We would get an area of 9 times 3, which equals 27 centimeters squared. Important again to have the right units. Okay? The next question was that we have a rope. And this rope has a length of 40 centimeters. 40 meters. Remember units here, it was different. This rope has a length of 40 meters. And we have to put this rope so we get the largest possible area. Rectangular shaped area. So what we would do then here is we'd turn it into, of course, a square, which is a form of rectangle. We've discussed this several times. So we would divide 40 by 4 to get 10 meters length. So we'd have 10 meters here and 10 meters here. And the question was, what would be the area of the largest shape that we would get? Well, then it would be 10 times 10, which is 100 meters squared. And, wait a minute, I'll go back to that later. Then the next one was, you have a plot, that is 4 by 2.5 centimeters. 4 centimeters, 2.5 centimeters. And it says, this rectangle, the one on this picture, is increased in the scale 3 to 1. So if we're going to increase it in the scale to 3 to 1 and calculate the perimeter and the area of the new scale, it means we have to have a new shape that is multiplied by 3. It's 3 times larger. 3 to 1 means 3 times larger. So we have to take our 4 and multiply that by 3 to give us 12 centimeters long. And we have to take our 2.5 and multiply that by 3 to give us 7.5 centimeters. So this is our new shape. Our new shape is 12 centimeters long and 7.5 centimeters high. Then they wanted the perimeter of this. Well, the perimeter would be 2 times the length of the length plus the breadth, which would be 2 times 12 plus 7.5, which is 2 times 19.5. 2 19s are 38. Add the half times 2 would get 39 centimeters. So the perimeter of our new scale in 3 to 1 would be 39 centimeters. Then we have to work out the area as well. And to get the area, we're using the formula length times breadth. So we need 12 centimeters long multiplied by 7.5 centimeters wide. Easiest way to do that, I think, is with a quick 7.5, and I put the one that's got the smallest numbers on the bottom. 1 and 2 is much easier. So we get 2 5s, 10, 2 7s, 14 plus 1, 15. Move one step to the left, magic 0, and then we get 1 times 7.5, so 7. So 0, 5, 10, 7, 8, 9. 1 decimal place in the question, 1 decimal place in the answer. So it equals 90 centimeters squared. So we get an area of that one of 90 centimeters squared. Then we have a plot that is 50 meters long in reality. So we've got a plot where the length of the plot is 50 meters in reality, and it's been scaled down to 10 centimeters. 10 centimeters. So the first thing we have to do is change these meters into centimeters. 50 meters is the same as 5,000 centimeters. So, what do we know? We know that our 10 centimeters is equivalent to the 5,000 centimeters that is the real plot. Can we leave it like that? No, we need to simplify. We need to divide both sides by 10 here, so we'd get 1 to 500. You always try and get 1 here, or the smallest whole number that you can. So this house, or this plot, is written in the scale of 1 to 500. It's our sketch is 1/500th of reality. Important here when you're going to do this is that you're comparing centimeters to centimeters. So you must convert this length in meters into centimeters. So the scale that we have for this plan is 1 to 500. Okay, and then we have the last question, where we have a painting, and we know that the scale that we've got is 40 centimeters squared, and it's a reduction. And the real painting, maybe we've taken a photo of it or something, is in the scale of 1 to 5. And the question is, what would be the area of this painting? Well, we have to think, if we were to say that this was X and this was Y, the area of this painting would be that X times Y equals 40. What would be the area of this painting then? Well, we know that Y would be 5 times larger, so it would be 5Y. And we know that X would be 5 times larger, so it would be 5X. So the area of, so if we call this area 1, the area of painting 2 would be 5 times X times Y. The length times the breadth. 5X times 5Y is the same as 25 lots of XY. But we already know that XY equals 40. So we substitute XY with the number 40. So we would get equals 25 times 40. 25 times 4 is 100. So, but we've got an extra 0 here. So we'd have 1,000 centimeters squared would be our real area. Okay? So I thought that